Hello, friends. My name is Desmond Edagisi, and I'm here to take us on the very interesting subject, geography. Today, we'll be looking at the theme, the Earth and the solar system, and we'll be learning on the topic, rocks. Now, there are various kinds of rocks, but today, we're going to be focusing on igneous rocks. Now, in the course of our class, these are some of the things I expect that we must have learned. First, we're going to get an introduction to what igneous rock is all about. We're also going to find out how these igneous rocks are formed from the scratch. Next, we'll know what the characteristics that distinguish these igneous rocks are. We'll also learn about the various types of igneous rocks. And of course, finally, we'll come to also learn about the economic benefits of igneous rocks. Now, before we go further in our class, let's know exactly what a rock is. And to do that, we need to study our planet Earth. Now, imagine our planet Earth, which is round, as we can see. Imagine if we were to slice our planet Earth in half. We would have 4 distinct layers. We would have the inner core, the outer core, the mantle, and the crust. Now, the crust is where we're going to be focusing on. The earth crust is where you and I live upon. We have the watery parts, which of course are rivers, lakes, seas, and the likes. And we have vegetation and a large mass of materials that cover the surface of the earth, known as rocks. Now, what exactly is a rock? A rock is a hard mass composed of one or more minerals. Rocks can be as little as a pebble, or even as large as a building. Rocks have history with man. Man have always found uses for rocks. For instance, man have found that rocks could also be used to develop tools for his hunting purposes. Man also used rock, to create weapons for himself, to defend himself and his family. And also, very importantly, man has found that rocks can also be used in the building of structures, accommodation for himself, and for monuments. Now, rock, like we said, is composed of one or more minerals. Some rocks, very few of them, are composed of just one mineral. Examples of such rocks are pyrite and quartz. Other rocks, or the majority of other rocks, are composed of 2 or more minerals. We'll take a look at some quick examples. Let's take, for instance, limestone. Limestone is a type of rock. And guess what? It is made of 3 distinct minerals. One of those minerals is quartz. The second mineral is feldspar, and of course the third mineral is mica. Sandstone is another kind of rock that is also composed of 3 minerals, which are quartz, feldspar, and also calcite. And finally, granite, which is another example also, is a rock composed of 2 minerals, feldspar and augite. Now, rocks are classified based on how they are formed. So we have 3 major classes of rocks. We have what we know as igneous rocks, which we're going to learn about today. We also have sedimentary rocks. And finally, we have metamorphic rocks. Now, what exactly are igneous rocks? The word igneous comes from a Latin origin. It is pronounced ignis in Latin, and it simply means born of fire. As we go into our class, we'll see why that particular word was used to describe igneous rocks. Now, igneous rocks are rocks that are formed by the cooling and solidification of hot, molten magma that comes from deep within the earth. Igneous rocks are extremely common in the earth's crust. How exactly is igneous rock formed? We've learned that it is the cooling and solidification of magma that comes from deep within the earth. So what exactly is magma. Since we said igneous rocks are formed from magma that has cooled and solidified. Now, a magma is a very hot, thick, viscous flow of fluid that is made up of the atoms and molecules of melted or partially melted rock particles and mineral particles under very high temperatures deep beneath the surface of the earth. Now, the melting of these rocks can be attributed to one or a combination of the following factors. It could be attributed to one, increase in temperature. It could also be attributed to increase in pressure. And it could also be attributed to change in composition of the particles of the rocks. Now, magma can be very mobile. And so, it may move in the process of its cooling and solidification in varying manners. One of those ways that magma moves is that it can be forced in between rocks to form what is known as dikes, seals, and plutons. So what exactly are dikes, seals, and plutons? Dikes are channels of rock that are formed when molten magma comes in between cracks that are within rock layers. This magma pushes its way into these cracks and cools and solidifies there to form what we know as dikes. Seals, on the other hand, is simply a molten magma that has forced itself also in between layers of rocks to cool and solidify to form what we also know as seals. And finally, plutons. Plutons are a large body. That is, there could be miles of magma that solidify and cool deep beneath the Earth's crust. Now, another way also that magma moves to cool and solidify is that it may also burst out in what is known as a volcanic eruption. That is, magma is pushed out of the surface of the Earth from structures known as volcanoes. When this magma gets to the surface of the Earth, it is referred to as a lava. Now, the magma that is pushed out to the surface of the Earth is fed from what is referred to as a magma chamber. A magma chamber is simply a pool that is deep within the Earth, full of molten magma. This chamber feeds the volcano from whence magma is pushed out to the surface of the Earth to become lava. The third way that magma moves is that it could also be pushed out of cracks within the Earth crust. So magma is simply pushed out of these cracks. And of course, when magma gets to the surface of the Earth, again, it is referred to as lava. Now, igneous rock can be classified based on where the magma that forms the igneous rock cools or solidifies. So, igneous rock that cools above the surface of the Earth or above the Earth's crust is referred to as volcanic or extrusive igneous rock. While magma that cools deep beneath the Earth's crust is referred to as plutonic or intrusive igneous rocks. Now let's take a look at the two kinds of rocks that we have. What is the volcanic or the extrusive igneous rock? This kind of rock is formed from magma that gets to the surface of the Earth either through cracks or from volcanic vents to form lava on the surface of the Earth. As this magma gets to the surface of the Earth, guess what? There is a change in temperature from where it is coming, where of course it is extremely hot. Now, the temperature that it meets at the surface of the Earth is far cooler, and hence we experience a rapid cooling of the magma to form igneous rock. This kind of rock that is formed is what? Small grained, and they form little crystals. Examples of this kind of volcanic rocks are basalt, you have the pumice, you have the andesite. These are some of the volcanic rocks, and you find such rocks, of course, around volcanoes. The other kind of igneous rock that we have are rocks, of course, that solidify and cool down beneath the Earth's crust. These rocks, we said, are called plutonic or intrusive igneous rocks. Now, these are rocks that cool and solidify. As magma moves up to the surface of the earth, just or before it gets to the surface of the earth, it cools and solidifies still within the earth's crust. Some examples of this kind of igneous rocks we find around structures such as seals, such as dikes, and the plutons that we learned about earlier. An example of this kind of igneous rock that is called intrusive or plutonic is the pegmatite. And this kind of rocks that form, they are coarse-grained and they also have large crystals. Now, there are certain distinguishing characteristics of igneous rocks that make them completely different from other kinds of rocks. Let's take a look at some of them. The first that we'll talk about is that igneous rocks are hard and impervious in nature. They are very hard and impervious. Also, they are crystalline in nature. That is, they contain crystals. Another factor or another distinguishing nature of igneous rocks is that they do not occur in layers. We can say they are non-stratified in nature. And lastly, they are resistant to erosion and other climatic factors. Now, igneous rocks have some very important economic values. For instance, granite is one rock that is very popular in the construction industry. Of course, we use granite in our architectural works, for roads, for dams, for all manner of buildings. Granite also has another very important use. It can be used as an abrasive for many different fields. Gabbro and basalt are also two different rocks that find use in the building or the construction industry. So we see that igneous rocks are very important rocks and have economic value to our lives. Now, we've learned so much today. Let's take a quick recap to see all that we've learned about. We learned firstly what a rock is. We said a rock is basically a hard matter composed of one or more minerals. We also learned that rocks can be classified based on how they are formed. So we have igneous rock as a type of rock. We learned about igneous rock today. We also said there is a type of rock also known as sedimentary rock, and also there is metamorphic rock. We also learned that the igneous rock is simply a rock that is formed by the cooling and solidification of molten magma. We learned that there are two basic types of igneous rock. We have the volcanic or the extrusive igneous rock, and we also have the plutonic or the intrusive igneous rock. Some characteristics of igneous rock that we listed today was that igneous rocks are hard and impervious, and also we said igneous rocks are crystalline in nature. Finally, we learned about some economic benefits of igneous rock. We learned about granite. We said granite can be used as abrasives. Granite, of course, can also be used in the construction industry. Basalt and gabbro, we said, can be used as aggregates also in the construction industry. So let's take one or two questions. Question 1. Which of the following is not a type of rock? A. Sedimentary rock. B. Endemic rock. C. Igneous rock. And D. Metamorphic rock. The correct answer is option B. Endemic rock. Endemic rock is definitely not a type of rock. Let's go to our next question. Question 2. Magma that cools above the Earth's crust is called A. Plutonic igneous rock. B. Flowing magma rock. C. Volcanic igneous rock. And D. Sedimentary igneous rock. The correct answer, of course, is option C. volcanic igneous rock. And so, class, we've come to the end of our session for today. It has been a wonderful time for me, and I'm sure you learned so much also. I hope to see you in our next class. Until then, it's bye for now.